Okay, hello, welcome to this tutorial. So I'm going to show you how to do the chemical injection and gas injection in this video. Okay, I want to build this video on an existing video which I already have on my YouTube channel. I'll put the link to that video in the description of this video, and I'll also send it to you directly. I'll recommend, in fact, you have to watch that video first, the video which I'll be sending the link to you, because the explanation of the keywords used in Eclipse and the structure of the Eclipse data file and all that, how to build a basic model, how to build a model in Eclipse. I'd gone through those steps in that video. So in this other one, which I'm doing now, I'll only go straight to the chemical and gas injection. So first of all, before we continue, I'll open up my simulation launcher for the Eclipse. Okay, so that's the simulation launcher. It's coming up. And then I have the data file for Visual Study Andy. What I'll do is I'll open them and then I'll explain, and then we can run the model and see the result. Okay, so that's what we're gonna do. First of all, I think some of the files I have here are not necessary because they are auto-generated by Eclipse. So let me clean up this folder and then we'll continue from there. Okay, so these are the files that are important. So I'll start with the gas model, the base case of the gas model. So I'll expand my screen, and then so if you go through the tutorial, which I'll send the link to you, you'll discover this is the basic structure of an Eclipse data file. We have the run spec section, we have the grid section. Okay, let me use my normal style. I use this to delineate the sections. So the run spec, the grid section, the props, the after the props we have the we have the edit, but I didn't use edit in this tutorial. We have the regions section. Okay, and we have the solutions, and we have the summary and the schedule. Those are the 8 sections for an Eclipse data file. But anyway, I'm not going to go through all that again. You'll get to learn them when you go through that tutorial. But what I want to point out is the phases. We have just 2 phases, fluid phases in this model. We have water and gas. This is supposed to be a pure gas model, so that's why I have just water and gas, and I'm using field unit in this model. The title is just a self-descriptive kind of. You can use whatever. This one you can write whatever you want here. For me, I just wrote gas model. You can change it to make it more elaborate to suit your project, and it should be on a single line anyway. Okay, so this is the start date. You can change this at any point in time, but for me, I'm just using that. Okay, so now I'm using the unified input and output so that the files generated will not be too much. It'll be put together. I've explained that in the other video too. Now in the grid section, we have the DZ shows is actually the dimension or the width. Yeah, let's say the width of the grid blocks. So the dimension in the x-axis, the dimension in the y-axis. Is that actually correct when it's a dimension in the x-axis? But it's actually the size. Okay, yeah, the grid size in the y-axis, the grid size in the x-axis, and then the grid size in the z-axis. So I'm using 75 feet in the x-axis, 75 in the y, and 30 feet in the z-axis, and then the permeability in the z-axis is 50 millidarcy. The porosity for the entire model is 0.2. The permeability in the x-axis is 500, and then the permeability in the y-axis is 500. The depth, the distance from the surface to the first layer is 4,000. Okay, I forgot to tell you, I'm using 8 grid blocks in the x-axis, 8 grid blocks in the y, and 2 grid blocks in the z-axis. So a total of 64 times 2 is about 128 grid blocks. That's what I'm using in this model. Okay, so this is my water saturation function, this is the gas saturation function, and this is the PVT of water, This is the PVT of dry gas, since I have just gas with no oil, so I'm not using the other keywords. Okay, so these are the rock properties, the pressure, and the compressibility. This is the density of the different fluids. We have oil, water, and gas, respectively. Okay, these are just reporting tools. I'm just reporting. So you'll learn all these things in the other tutorial. Let me go directly to the summary section. I mean the schedule section, because that's what is important. So we'll look at the well spec section. We notice we have just one well here. The well is named P. I'll also tell you here that the naming of your well is absolutely flexible. You can call your well whatever you want to call. So I can change this well to maybe call it Promise or whatever name. But the convention in fields in the industry is the name of the model. The name of the field hyphen the number of well. So let's say the field is called MBL. So if this is the first well, you can say MBL 1, or maybe you can use an acronym for the field. So like MBL can be called NIP01. So this is the first well in this field. So the 10th well will be MBL 10 as a convention. But for this model, I'm just going to use P. So I just brought that to notice in case you look at other models and you see other things like that. So you are at liberty to call your name, your well, whatever. So the next thing here is the group. So I'm placing this producer at the grid 88 as at the extreme of my model. I'll visualize this model in flow grid so that you can see. FLOVIZ, so that you can see the model. So I'm setting the datum depth is 4000 and it ought to be a gas producer. So the completion, I'm perforating the second layer. Since we just have 2 layers, perforating the last one. The internal diameter of the well is 0.5. Okay, so I'm opening up the well here in the well control keyword, and what I want to control is the gas rate. So that's why I'm defaulting the oil rate, but I'm specifying a water rate of 1000 stockton barrels per day. That is, if water production exceeds this rate, what I'm telling the Eclipse to do is to shut down the well. That's what it means. If it exceeds this, shut down. The same thing with the gas rate. So this is where I'm controlling the gas rate. I said the gas rate should be 10,000 standard cubic feet. Anyway, the unit used by Eclipse is 1000 standard cubic feet, right? So if I say 10,000 standard cubic feet, I'm actually specifying 10 million standard cubic feet. So I'm asking Eclipse to put the gas rate at 10 million scoff per day, right? I'm defaulting to other keywords, which are the liquid rate and the reservoir voidage. Now I'm putting the bottom hole pressure for this well to be at 50, so it should be maintained at this. If it's lower than that, you shut the okay, yeah. That now the time step, I'm getting my report every 30 days for 120 times. That's we know that 12 times. So 30 days is 1 month, right? So 12 times of 30 days will be 1 year. 120 times is just 10 years. I'm getting my report for just 10 years every 30 days. That's all for this. So that's the base model. I'm going to split the screen and place it somewhere else. Okay. Now let me go and bring up the other one. Now I have the gas model. Gas model is just, this is where I am injecting gas into the model. So it's the base model, but now I'm injecting gas. If you look at it, if you compare both of them, you discover the properties are the same. The only place the properties differ, or the keywords differ, or the data file differs is in the schedule section, where I place a new well. So if you look at your well spec section, you discover we have 2 wells now. This is one. So I placed another well, which is a gas injector. I call it IG, that is injector gas. Like I said, you can call it anything you want. And okay, so here I'm saying my injector, I'm also perforating the second layer. So that means I'm injecting the gas at the second layer, where I'm also producing oil at the second layer. So the diameter is the same, all other properties. I'm keeping these things consistent. So the diameter of all my wells, they are the same, like, just because it's a sort of comparative study, you're trying to compare. So that's why I'm trying to keep these things the same, so that whatever you're comparing, so that you can do the comparison well. Okay, so now I'm using the Vulcan inject keyword. So I'm injecting the gas at the rate of 1,000 cubic feet. That's about 1 million standard cubic feet per day. So a million standard cubic feet every day. Okay, so that is what I am doing. Okay, the timestamp. Sorry, I have to correct this. So I want to use this timestamp as the same timestamp I'm using for all the models. Okay, that's that. So let's also look at the other one. Now let's look at the polymer situation. So for the polymer, if you compare the polymer to the base model, it's almost the same. The only thing here is I used the polymer keyword here. There's no keyword like that. So because I want to do polymer injection, chemical injection, but the chemical is actually polymer and all that now. So because I'm doing polymer injection, I have to use the polymer keyword. So if I'm doing foam, I'll use the foam keyword and all that. So I'm using the polymer keyword to tell Eclipse that I want to do polymer. So there are other keywords which you have to use if you've activated the polymer option. The keywords include this. So from this up to this. So the first one is the polymer viscosity that specifies the viscosity of the polymer. So you use this keyword to specify that we have the polymer, the interaction of the polymer with the rock. So the polymer rock keyword, the polymer adsorption keyword, the ADSA is for adsorption. That is adsorption. Yeah. So okay. So and then I am using the toad load mixing parameter. So and then this is actually mandatory if you're doing polymer injection. Then the polymer maximum concentration. Polymer maximum concentration keyword. So I'm saying the maximum concentration should be 50. You can alter this in these things. If you want to conduct sensitivity analysis, you can alter these concentrations so as to allow you to maybe increase or decrease. Now let's go to the schedule section. So in the schedule section, I have a well called IP, so injector polymer, and then the properties are the same. I'm placing it at grid block 1.1, but I don't. Let's use the same grid block for all of them. So I want to place it. Okay, sorry. It should be at 1.1. I think that's where I placed the gas, right? Yeah, 1.1. Okay, so grid block 1.1 is good. I'm placing it at grid block 1.1. That's the other extreme of the model. So the producer is at one extreme, the injector is at the other extreme. Okay, so I'm perforating the second layer too, and then I am injecting. Notice it says we're injecting water, but that's not actually true. There is no option like inject polymer. There's no option like polymer here. The only possible options are water, which is what, oil, which is oil, and then gas, which is gas. So just three characters. So since there is no option like polymer, you have to specify it as water, and then you use the W polymer, that's the well polymer, or the water polymer keyword to specify the concentration of the polymer in the water, right? So that's how you change it from water to polymer. So now the rate at which I'm injecting is 2,000 Stockton barrels per day. That's what I'm doing. Then I'm also getting the report. Okay, now the last one is where I am combining all of them together. So here I'm combining both the gas and the polymer together. So if you look at the well spec section, the schedule, you discover I have two injector wells here. You have the IP, which is the injector polymer, and then IG, the injector gas. So I have changed the location of the wells. we'll visualize this in FLOVIZ. Okay, and then perforating all of them at the second layer. Their radius is the same, and then you will notice I'm injecting water at 2000 and injecting gas at 1 million standard cubic feet. So this is just to change it from water injector to polymer and all that. So okay, and it also changed this to the time step. So the time step I wanted to be this. Okay, so we're done with that. Alright, that's for the gas model. I just want to run this and then we'll also look at the oil model. Now look at the folder, the way the folder is at the moment. We just have these files. Now if I run this model, you discover other files will be generated. Those files I cleaned up the other time. So you can always clean them up, but don't clean up the main data file. Now notice these files are of type data. So these are the main data files. You can clean up any other thing, but don't clean up the data files. Because if you do that, you've lost your model and you have to do it again. Okay, so I'm going to use the simulation launcher to run this. So I'll go run Eclipse. Because of license issues, I'm going to run the 32-bit version, which will override the license requirements for me. So I go to dataset, add datasets, and in the chemical injection folder, I'll select everything that has to do with gas. So those are the 4 models, and I open them, and then I click on run. Okay, these should run these models for me. So it's running, as you can see. So once you're done running, then we can now open it and view the results. Okay, we're done with this one now. So no errors. And this one too, no errors. Okay, so now we can actually open Office to view the results. So I'm gonna run Office. So I'm running the 32-bit version of Office, and I click on run. So I want to view results, so I go to results. Now all I have to do is go to file and open summary, load all vectors. Okay, before I continue, I'd love to show you the folder, how it looks like. You see, there are a whole lot of other files now, right? Okay, so that's how it looks like. Now the files that Office needs are the SPEC files. So I'll select all of them and then I'll open. Now in my schedule section, sorry, I think the summary section, not schedule, yeah, the summary section, I asked Eclipse to output some files for me. I requested for the water code FWCT, that's a field water code. So if you open any of these, you should see FWCT. So that's that. So whatever you ask Eclipse to output, sorry about that. Whatever you ask Eclipse to output here is what you'll get here. So you have to be careful what you output. So anyway, I just want to bring that to notice. So now let's just I'll start by looking at the average pressure. So I'll look at that, and from this result we can see that the pressure declined very quickly. We had a very sharp pressure drop from 500 psi to about this is 100, so 24 is 60 to 60 psi in less than, this is 1,000, then it should be 400, and that's in about 200 days. First 200 days we had this sharp pressure drop, then after that we had a sort of constant constant pressure after that. Okay, but let's look at that is for the base model. Notice that was base model. You can look at it here, gas model base. Now let's look at what happened when we injected gas. What happened? I'll right click on this and add it to the current graph. Right click, add to current. Okay, so when we started injecting gas, we discovered the pressure increased to a certain point. I think almost the same period here, and then before it started coming down. Okay, right? But at least we have an increase in pressure. We have increase in pressure. Okay, so let's look at the polymer injection scenario. Polymer injection, what happened to the field pressure? Wow, this is serious. Wow, I'm saying that the field pressure rose from whatever value it was at, less than 500 to 100,000. Ah, that's serious. Could injecting polymer have this kind of effects? Okay. That's serious. Okay, that's how we have it. Okay, so let's look at what happens when we inject both polymer and gas into the model. When I inject polymer and gas into the model, what do I have? Okay, it's almost the same as injecting only polymer, although there's a slight increase, which we cannot really notice, but there's a slight increase there. At what rate were we injecting the polymer? Let's look at the polymer. Injecting polymer at 2000. Wow, I think that's a very high rate. That's why we add that. You might want to reduce this rate and see the effect it will have on the field pressure and other parameters. Okay, that's great. Now that's for the field pressure. Now let's look at the gas production rate. What effect does let's look at the base model first. Discover we have increase up to a certain point and then a sharp drop, and then after about this is close to, what do we have there, about 200 days, okay, 100 and something days, almost 120 days. So there's no production at all. We're not producing gas again. That's serious. Okay, let's look at that's for the base model. Let's look at when we're injecting gas into this model. What happens? Well, okay, so when injecting gas, we'll actually increase our production and keep it at a steady rate of 1,000. So this is 1,000 standard cubic feet. This is what I was trying to tell you. The unit is usually 1,000 standard cubic feet. So 1,000 standard cubic feet is about 1 million standard cubic feet. And I think that was the rate at which we're injecting the gas, right? Was that the rate we're injecting the gas? Yes, we're injecting the gas at that rate. So basically, it's the gas you're injecting that you're producing. Wow, that's serious. Okay. This will actually beg the question, what was the quantity of gas in place? We'll look at that in a bit. Okay, so let's look at the polymer option. So gas production rate. So I'm gonna add that. Oh, that has no effect on gas production. In fact, injecting polymer is like you're not injecting anything. Oh, but why would that be? Gas polymer. Okay. Why would you have that? Okay. Anyway, as that, let's look at when you're injecting both polymer and gas into the model. So this is what you have. There was no production up to a certain point where the production started increasing, and up to that. Okay, so that's great. I want to look at these polymer again. I want to look at it separately to check. Okay, there's no production at all. I'll remove that from. Okay, so that's great. Okay, so let's also look at the gas in place. So we actually have gas at all in the model because of the results we're getting for the gas produced here. So I'm going to start from the base model too. Field gas in place. Yeah, we actually have gas. It's about 16 million scuff, about that, above that, or something. And then it dropped to about 5, yeah, 5 million. And then if that's the case, Uh, okay, no problem. So we can also look at other parameters, like a whole lot of other parameters that you can check if you're producing gas or oil at all. But I don't think there'll be any oil since we did not specify the vaporized oil keyword to signify that we have wet, that it's a wet gas. We only use the dry gas keyword, so there should be none. But to to avoid doubts, we're gonna run this. So if you look at that, you discover there is no oil production at all. Okay, so that's great. Then we can also look at water cut. If you're producing water, you can look at the rate at which you're producing. Let's look at water cut. We discovered the water cut was about 100% up to a certain point where it dropped to 0%. Why would you have? Okay, sorry, that's 1%. 0.5. Yeah, no, water cut of 1 is actually water cut of 1 should be 100%, right? Okay, no, but let's look at other ones to know if I'm actually correct in that assumption. So I'm gonna add this to the current graph and wow. Okay, water cut is usually in percentage, so I pray this should be 1%. Yeah, it should actually be 1%. Okay, but we're having a constant one one all through for the gas injection scenario. When we inject polymer, let's see what we have. So add to current. Okay, it's also constant at 1 all through. I think the lines are too thin, so I'm gonna click on the legend there, then line thickness. I'll increase that to a certain point, then I'll apply to all lines in all picture. I'll apply and reset. Okay, so I think it's thicker now. Now we can also look at water cut when we're doing this gas polymer stuff. So water cut, and it's the same thing. We're having the same issue. Okay, so uh, okay. Now we can also, the other things you can look at. Maybe you can decide to look at the cumulative gas produced (FGPT). So if you look at cumulative gas, that's for the base model. If you look at for the gas model, let's look at that together. Okay, there is a significant increase. So what happens with the polymer injection model? There is no gas production at all. That's terrible. Okay, and then let's look at for the polymer and the gas injection scenario. We'll look at that. Right click and then this. Okay, so we see a gradual increase after some time. Okay, so that's the results we're getting. That's the results we're getting. Okay, possibly these no production for the polymer injection scenario can actually be as a result of I think the pressure we're getting here when we injected polymer. This pressure I think should be enough to rupture the rocks and all that and make it to crush. So I think that should be the reason for that. So I'll recommend that you reduce this injection rate and see if you'll have something different. But anyway, I'll leave that to you. I'll not do everything. Right. Okay. So that's for the visualization in Office. Now I had used the Excel keyword in all these data file. Use the Excel keyword so that we get an Excel readable value. Now, before we go to Excel, let's look at this. If you're not comfortable with the way these graphs are being plotted here, I will show you how to format it anyway. I'd shown you one when I clicked on the legend and I increased the line thickness. There are other options which you can also do here. You can select all those ones. You can customize. I personally, I don't like grid lines in my graph. So what I'll do is I'll click on this as is, and then I'll go to style and I'll say grid lines. I'll deselect that. So I'll do that also for this as is, and then I'll go to style and deselect the grid line, right? So if you've applied all the changes you can think of, and you're still not comfortable with the way the graph is plotted here, by the way, you can save this graph, right? You can export, and then another way is you click. Well, what's the way again? No. I think it's safe. There should be a save. It's okay. Yeah, save to bitmap. Yeah. So you can save current picture or active graph. Any of this. This will save it as a JPEG file, right? So if you're not comfortable the way it is, you can click on this icon, and then this is the data used to plot this graph. So you can right click and then export table export. Now you can export to clipboard, which will remain in your. No, when you do Control C, when you copy something, it goes to the clipboard. So if I export to clipboard and I click OK, I can paste it anywhere. I can go to Excel and paste. I can paste on any text editor or whatever, or yeah, or data sheet. Now you can also export it to file, specify file name and a folder, directory, and export. But I'll use the clipboard option. So I'll do OK, and now I can open my notepad, and then if I do Control V, so that's the data I copied. Okay, so if you don't want to do that too, now you can go to your folder. You'll discover you have an RSM file. So RSM file, which is Excel readable. So all you have to do is for each of the models, you can just open the RSM file, and you'll see the data there. So once you have the data, you can do with it as you want. If you have it in Excel, you can plot graphs in Excel. You can take it to Python. You can take it to MATLAB or whatever tool you're comfortable with, and you plot your graphs there. That's the essence of asking asking Eclipse to dump this data in this Excel readable file. So that is that. So we'll wait for this to open, and then we can proceed with the others. Okay, so that's the data. So you can see it's Excel readable, right? Properly formatted. So that's wonderful. Okay, that's that for you. Now you have to take note of the units. Gas is always in 1,000 standard cubic feet. Very important. You have to take note of that. Okay, that's all for now. Okay, now let's also look at now let's visualize these in FLOVIZ. Now I can easily click on this. You look for an eGrid or a grid file, a file of type eGrid or grid, and open. Or you can go to your simulation launcher, and then you launch FLOVIZ from there. So this is FLOVIZ. I'll run the 32-bit version, and I'll run it. To launch FLOVIZ from there, and then you can get the file and open. So this is our FLOVIZ. It's still coming up. Finally. Okay, so that's the FLOVIZ environment. All you have to do is go to File, that's Open. Or you can do, it's either you click on that icon or you do File, Open, Eclipse, right? Any of those options. So I'll go to Chemical Injection and locate any of these. Let's start with the base model. So I'll do that, Open, then just click on OK. So that's that. Our wells, it's actually showing, but I can't see it very well at the moment. So I'll go to this point, and I'll select all these, and I'll increase the width to 3%, and the height to 2, right? And then I'll set this, I'll apply, and then let's see. Okay, so that's our well now, and then I can close. I can apply. Okay, so I can increase this. So I know you've seen the well. That's the well there. Okay, so that's that, and this is our legend. Or what again can you do? So I love to run this now. This is the pressure. What you're seeing here is pressure, but you can change it and look at something else. We can look at gas saturation, right? So you discover this is the point with the highest saturation. All you have to do is just look at this, the legend here. So the red line shows more that this region, any region with red, is more saturated with gas. So the saturation increases this way. Now, if you run this model here, you'll discover what's happening. So that's what we're having. So the regions that were less saturated with gas, they certainly started having gas. And I don't know. Now you discover at the end of the day, our well is shut in. I don't know if you noticed that. Let's go to the beginning again. Do you see the color of the well? Now when I run, just notice what is happening. At some points, it's still running, right? Now notice the well changed immediately. While we're still running. Okay, now it has stopped. So at some point the well stopped, was shut in. So at that point you can actually look at your graph to check at which point the well actually shut in when there was no production again. Let's look at our gas production rate. So for the base case, okay, so this was the point at which there was no production again. So probably this was when the well was shut in. Okay, so that is that. You can look at other ones. So I'm gonna remove this one and then open another one. So let's look at for the gas model. Okay, so this is our injector. Like I said, I place them at the extremes. This is the injector at one extreme and the producer at the other extreme. So let's see what happens if you run this model. Wow, that's for pressure. I want to look at pressure. I want to look at gas saturation. Okay, so I'll go to the beginning again. So you discover this is how it is, and then when you run, this is what you get. So gas is coming in, and everywhere now becomes saturated with gas. It's still running. Okay, still running. We're still producing. Okay, now it stopped. Okay, so that's that. Then you can compare what you're seeing here to what you have in your graph, so as to understand what's actually happening. Now, I want to show. Just want to do one last one. Uh, I'll not look at the. I'll just look at the polymer and gas model here, and so that we can look at the oil business. Okay, so this is what is happening. That's the injector for oil, for polymer, the injector for gas. You can change this location. You can maybe bring the injector for gas maybe to somewhere here or here, whatever. But if you do your grid estimation very well, you'll know where to place this. So those are one of the things you can actually change and make so as to customize the model to become yours the way you want it. Okay. So now if we run this, let's run this and see what results we get. I need to view the results for pressure, for not pressure, but for saturation. Okay. We see there is no. Okay, so now let's run this. Nothing is happening. Didn't we? Is there something we did wrong? Let's see, polymer. I think we did not output this thing, did we? We didn't output anything. Let me look at gas polymer gas. The reports section. I did now. So why we're not having outputs here? compare that with some other thing. What did we output here for the report props? It's the same thing now. Report it. Let me just split the screen so as to be able to compare one. Okay, so I just want to look at the what I actually output in this ones. The output is the same. The only difference is I included this keyword. Okay. Anyway, that should be okay. Okay, so obviously we can't view the result here. I don't know, maybe I'll check that some other time. Okay, that's that for the gas scenario. So for the oil, it will be the same thing. We'll have to go through the same process again, but I think I'll not spend time the way I did for the gas, since you already understand how it is. So let's look at the oil scenario. Okay, so this is oil. Now the oil model is almost the same thing, but change the dimension to be 10, 10, 3. The phases we have is oil, gas, and dissolved gas. The gas here is just open to do gas injection later on. Okay, so we have what again? You can go through these properties later on. So I'll scroll. I'll have to send this file to you maybe later on so that you can go through them. But what concerns me is the schedule section. So we have well spec. We have just one well here. That's whose primary phase is oil, and then the well we prefer the third region, the third layer, and we want to produce oil at 20,000 barrels per day. Right, that's what we want. That's for the base model. Let's look at the gas model where you're injecting gas. So for this scenario where I'm injecting gas, I have another well there, injector gas. Okay, whose primary phase is gas. Then I'm also perforating the same layer, the third layer, and I'm injecting gas at 1 million standard cubic feet per day. Right. Okay, so that's that. We'll also look at the polymer option, polymer file. Here it's the same thing, but I've activated the polymer keyword here, and then I'm using the same polymer properties for the other gas scenario. So if you compare this, you discover they're the same with the other one. So this thing is actually two long stop mixing parameter. Okay. Then so if you look at this section, we have injector polymer perforated at the third layer, placed at the first grid block 1,1. Then we're injecting polymer, that's the concentration of the polymer and all that. We're injecting at 2,000 standard cubic feet per day. Like I said, you can change these values, all these ones, to see what effect it will have. Right. Okay, and then this is the last scenario where we inject both polymer and gas at the same time. So this is that inject. So we have two injectors here, and those are the properties. So what I'm going to do is I'll just run the model at once so that we can proceed. So I'm going to add the data sets. I'm injecting all the ones that contain oil, and then I run. So we've all completed running with no errors. So we can now go to uh, Office to see the results we'll get for them. So I'm gonna close this ones. I'll import the other ones, the ones that contain file. Okay, so we can also do the same thing we did. We can look at, since this is an oil model, I'll start by looking at the oil rate at which oil rate you're getting. See, F O. Okay, let me start with the base model. This is the base model. So oil production rate. Now you see that. So let's quickly look at, for the case of gas injection, the oil rates. Okay, there's an increase in oil rates. Then we can also look at the polymer situation as the effect of injecting polymer on the oil rates. Yeah. That's great. I think this is sweet, better than for the gas model. Okay, and then let's look at combine, where we combine the gas and the polymer. Okay, that's the best. Okay, so I think this is actually very good. Okay, so you can do the same thing for other parameters like the average pressure and others. So I'll leave those ones for you. I don't want to spend more time again. Okay, now that's that. You can also go to FLOVIZ and view your results and run them and see what's actually happening. Then from there you can now interpret and write your report. So I think that's that. I don't know if there's another thing which I have to say, but I think I've done justice to that. Okay, the other thing which I'll love to say is if you have questions on how to use some of those keywords, you can consult the manual. It comes with a simulation launcher with a default installation. So you click on this and you have this and you click on run. I should open up your default PDF reader. My default PDF reader is FLOVIZ reader. So with this, you have everything you need. So if you go to the technical description or reference manual, any of those, let's look at technical description. You'll see the keywords. So for instance, you want to look at the polymer keyword. I can type polymer, and yeah, it takes me there. So from there, I can read a whole lot about the polymer keyword and all that. So that's then you can also look at the reference manual, right? And then let me also look for polymer and see. So okay, that's not polymer. I need polymer as a keyword, not that I need. So I'm gonna look at the settings. I need all words on the okay. That's happening. Take me to polymer now. Okay, but some of the keywords you actually used, I think it's, where is it? Okay, this polymer, so I can click on polymer. So it says activates the polymer fluid model. So you can also look at some of those keywords like the tooth, long staff, mixing parameter, and all that. So just to know what they actually are and how to use them. So that's that for this tutorial. That's the end. I wish you success. If you have questions, don't hesitate to ask. Do well to share the tutorial and then recommend, like, and don't forget to subscribe. Okay, bye for now.